Hi everyone, this is lesson 1.3.4 on angles and sides of a triangle. So this will conclude the chapter 1 that we're working on. And so we've been talking about angle relationships with parallel lines, without parallel lines. And so now we're going to start to transition into taking that same knowledge and applying it to shapes and how they relate to the sides of those shapes. Okay, so here's the first one. We're talking about triangles, and some of you probably already know this, but maybe don't know there's an official name for it. So triangle angle sum theorem is, in summary, really just means all the angles in a triangle add up to 180 degrees. All right, so here's kind of more of an official definition. If a polygon is a triangle, then the measures of its angles sum to 180 degrees. So sum meaning add up to. All right, so if we look at this visual, so here I have a triangle highlighted for us. So if I take, so just so you're clear, this is our, here we have just a normal triangle. And so what we do know is, in previous lesson, we talked about parallel lines. And so if I look at these parallel lines that are given to us in this diagram, and we think about these transversals like we've seen before, then we can start to apply some of the angle relationships we already know. So the main angle relationship we're looking at is that this angle here and this angle here, A and D, are known as alternate interior angles, and those are congruent. So that means angle A and angle D are the same. So I'm going to mark this. So angle A, let's see. And we also know, if we focus on these parallel lines, and this other transversal, oops, that we also have another pair of alternate interior angles. So alternate interior angles are congruent. So then therefore angle C and angle E are the same. So let me mark those. So these, all right. And then angle B, question is, well, angle B, how does that relate? Well, B is just B, all right? So B is part of the triangle, and you'll notice if I complete this half of a circle, which we know that when we have half of a circle, that's 180 degrees. So that must mean that if I take D and I add B to it and E, it should equal to 180 degrees. So that's what I know about these three angles. Well, those happen to be the exact same angles in here. Let me put a different marking here. So if I take this, right, so here we have the triangle, those three angles in the triangle. Oops. Those three angles in the triangle, we know it doesn't matter if they're the same measurement or not. If I take those three angles and I put them here, you could see that, again, this angle here, C, is the same as D. I'm sorry, E is the same as C, and D is the same as A. All right, so if these three add up to 180, then that must mean that these three must add up to 180. All right, so that's kind of a long explanation of maybe something you already knew, but didn't know exactly why they add up to 180. So there's one proof of it that it's good to know, just to verify that those three angles will always add up to 180. All right, so it doesn't matter the size of the triangle or the measurements of the triangle inside, they will always add up to 180 degrees. All right, the next conjecture that you need to know is the triangle inequality conjecture. So can a triangle be formed with lengths of any size? So most of the time, like if there was a test question and I drew in a triangle and I gave you some measurements, if I said, oh, this is 100, this is 1, and this, 100, this is 1, and this is 2, you might not question it, right? But the reality is this triangle is impossible, right? If this was drawn to scale, it would be impossible for us to draw a triangle like this. And so the question is, what is possible? All right, so if I look at these measurements, would 1 centimeter, 5 centimeters, and 2 centimeters work to create a triangle? Well, I've kind of drawn this out for us. So if I have one that's 5 centimeters, one side that's 5 centimeters, and I have another one that's 1 centimeter long, right, the actual length, and then another that's 2 centimeters long, is it possible to form a triangle? Now, I've drawn them out there, but they could be moved around. And so if I want to rotate, if I say, well, what if I stretch it out a little bit more? Well, it's never going to really be longer, right? So it's not going to be as long as we'd like. And it doesn't probably help if I make the angle bigger. Right? So there is a limit to how far it could reach. So it doesn't matter if I make it lower and this one lower, they're never going to touch. So this is going to have a maximum distance. All right, so if this was not 5 centimeters, if it was smaller, maybe 1 centimeter, then maybe those would end up touching. So if this doesn't work, then what measurements will? Right, so there's not necessarily one specific measurement that always works. There could be a variety of measurements that work. So this is what you need to know. Each side of a triangle must be shorter than the sum of the other two sides and longer than the difference of the other two sides. It's kind of a long definition, but let me try to re-explain that to you. So if I take two sides, so like 1 and 5, or what does this say? Shorter than the sum of the other two. So if I take 1 and 5 and I add them together, that's the sum. Is the other side shorter? Yeah, it is shorter. And longer than the difference of the other two sides. And so if I take the difference, 5 minus 1, that's 4. Well, 2 is not longer than 4, so that doesn't work. So we're using this as a guide to help us check to see if it's going to work or not. All right, so a little bit more specific and an example. So sometimes the words are confusing. Here's kind of more of a mathematical explanation. So if we are given, sides A, B, and C, so assuming we have the measurements of a triangle called A, B, and C, what I know is that the third side, it's called C, the third side has to be greater than the difference. So that means I'm going to subtract the two sides. And you notice I put absolute value because I don't want any negative numbers. So that's just to make sure we don't get any negative numbers. And then that C, the third side, also is going to be less than the sum of those two sides as well. So you'll notice all we're really doing is subtracting and adding. So if you know how to subtract two numbers and add two numbers, this should be pretty easy for you. So when we subtract or find the difference, this is us finding the minimum, and when we add them, this is us finding the maximum. So we're not solving for the value of C. We're solving to find out what value C can be, and it could be more than one. All right, so specific example, I'm going to zoom into this one, is if I have 5, 3, and 10, so 5, 3, and 10, those are my measurements, and I want to know if this is an actual triangle or not. So the first thing I would do is figure out the minimum. All right, so I'm going to find the difference. So 5 minus 3, which is 2. And I'm going to find the maximum, 5 plus 3, which is 8. So now I know the minimum and I know the maximum. And what I know is that third side has to be in the middle. So this is what I'm looking at. So 10 is 10 in between 2 and 8. Now 10 is greater than 2, that's true. But 10 is not less than 8. So this is false. Right, so this is a false statement. False. So that means we've determined that this is not a triangle. And so if it was, if we wanted it to be a triangle, and the second question to this could be, what can I change this third side to so that it does work? So if I change it to a 9, would that work? Well, 9 is not less than 8. So I have to think of a number that's less than 8. So can I choose 7, right? So does 7 work? Well, 7 is greater than 2 and 7 is less than 8. Yeah, so 7 is not the answer, but 7 could be an answer. 6 could be an answer. 5, 4, 3, right? Maybe even 2.1, right? 2.1 could work, or maybe 7.99 could work. All right, so if I put in 8, 8 is not less than, all right, so that's 8 will not work. 2 will not work. But 2.1 can work. All right, so as long as it's bigger than 2 and it's less than 8. All right, so we'll practice some of that in a little bit, but that's kind of what you need to know on that one. And then the last relationship you need to understand relates to the sides and angles of triangles. So here we're looking at the longest side and the largest angle conjecture. So here's a triangle given to us with all the measurements. We know the length of each side, we know the angle measurements. What do we see? What do we notice? So probably one thing I would check to see if this is actual triangle would probably be to see if all these angles add up to 180 degrees. And so they do. All right, so all those add up to 180 degrees. 127 plus 32 degrees plus 21 degrees equals to 180 degrees. So that's what I notice, which is good. So that's a good sign that this is probably going to be a triangle. And the other thing I'm looking for is the measurements, 4, 6, 9. And so those are close in size, so that's probably a good hint that it's most likely an accurate triangle. We would have to test it out using the inequality conjecture. But the other thing I wanted us to notice or focus on was, what is the longest side? All right, so if I look at the three measurements, I have 4, 6, and 9, which of the three is longer? So hopefully you notice that would be 9 centimeters. All right, so I'm going to fill that in. Longest side is 9 centimeters. And then what's the largest angle? Well, the largest angle is, what's larger, 21, 32, or 127? All right. So I'm going to put 127 degrees. All right. So I'm using the angle actual measurements instead of the names of the sides and angles, but it should work out the same way. And so the next thing I want to do is focus on the smallest. So what's the smallest side? All right, so this would be 4 centimeters. And the smallest angle is going to be, I believe that's 21. All right, so if you didn't notice, so the longest side was 9, and the biggest angle was 127. So look at where they're located. So I noticed that the side is directly opposite of the angle. And when I look at the smallest angle, and directly opposite it happens to be the smallest side. And so if the largest is opposite of the largest, and the smallest is opposite of the smallest, then that must mean the middle one is going to be opposite of the middle one. All right, so that's kind of the basics of what you need to know. So if for some reason I change these measurements, if I move the 32 over here and the 21 over here, you should see this triangle and say, this triangle doesn't make any sense. Because 4 is the smallest side, but 21 is the smallest angle. So that would be wrong. That would be wrong. So when I notice all these, the small is across from the small and the big is across from the big, that tells me that this triangle is drawn out correctly and the measurements are put in the right place. All right, so if an angle is the largest or smallest in a triangle, then the longest or shortest side is opposite it. All right, that's basically what I've been saying. All right, so there's more of an official definition. If you haven't already noticed, I've been trying to put key definitions in boxes. Usually they're like this orange box for you. All right, and I'm going to do one more problem with us. I'll leave this on the screen a little bit longer. All right, so I wanted us to practice our inequality. And so this is a simple test question that most people get wrong for some reason. And so the question is, can you determine the minimum and maximum lengths for each missing side in the triangle? So if I have a triangle like the one given to us, so I'll zoom in for a second. And so I have this triangle, and I have 2 of the measurements, 13 and 19, but I don't know the third one. The question, a lot of times people want to figure out what's the missing measurement. And maybe they're familiar with Pythagorean theorem, and they start to do calculations, and they say, oh, I think I know what it is. Or they add these 2 together, and they think, they're like, oh, I know the answer, it's 32. No, that's not true. So there is actually more than one answer. So since there's more than one answer, we can't give one solid answer. So the best we could do is figure out what the minimum and maximum is. So I've started this for us. So I know that this segment DF is going to be somewhere between the minimum and maximum. So if I want to find the minimum, all I do is take these 2 sides and subtract them. 19 minus 13. If you want to do absolute value, you could do that as well. Just make sure you don't have a negative answer. And then 19 and 13, you're going to add those. So the only difference is here's a minus and here's a plus. So then if we add those together, the question is, what do we get? So 19 minus 13, this is going to be 6. And 19 plus 13 is going to be, what is going to be, 20, oops, not 20, 32. All right, so that means this segment, DF, is going to be somewhere between these two numbers. So it might be a 7, it might be an 8, it might be 12, it might be 30. If I say it's 32, that would be wrong because it's not less than. If I say it's 50, that would be wrong. So it has to be between these two numbers. All right. So the last one, I'm going to let you try that on your own if you want to try to practice that one. If you need the answer to that one, let me know. And I think that's it. Yeah, that's all my notes. So hopefully this was helpful.